Marhaban! Today we're going to talk about dividing polynomials and special products of binomials. Before you can do this, please make sure you've done the notes about multiplying polynomials, otherwise this won't make any sense at all. Also, I've posted an outline of this in Google Drive. Okay, let's start by dividing polynomials. So to divide polynomials, we're going to use the box method, but just a little differently from when we multiplied. So for example, we got 2x squared minus 11x minus 21 all over 2x plus 3. Well, what we're going to do is we're going to write that 2x plus 3 on the outside of our box, so 2x plus 3. And we don't know what goes inside. But since it's a quadratic, remember that means degree 2, we're going to assume that what we're multiplying by has two terms as well. On the inside of the box, we're going to fill in some of the information from the numerator. So in the top left corner, we're going to put the highest degree term, which is x squared. In the bottom right corner, we're going to put the lowest degree term, which is negative 21. And then we know that these diagonals need to add up to negative 11x. Okay, now ask yourself, what times 2x gives us 2x squared? Well, that's just x. Okay, then what times 3 gives me negative 21? In other words, negative 21 divided by 3 gives me negative 7. And if we did this right, if we're correct, then when we finish these two boxes, we should get a total of negative 11x. So x times 3 is 3x. Negative 7 times 2x is negative 14x. Negative 14x plus 3x is negative 11x. So we're right. Our answer is x minus 7. Let's try another one. Okay, we got a rectangular window. Its area is 15x squared minus 26x plus 8. We know the length is 3x minus 4. We need to know the width. Well, we should know by now, I really hope you do, that the area of a rectangle is width times length. So that means if we have area and divide the length, we get the width. So on the outside of our box, we need 3x minus 4. And we don't know the width. And since our area is quadratic, we're going to assume that our width is going to be a binomial. Okay, top left box goes the highest term, or the term with the highest degree, which would be 15x squared. Bottom right box, we get the term with the lowest degree, which is just 8. Okay, so what times 3x gives me 15x squared? Well, we know 3 times 5 gives me 15. And then x times x gives me x squared. So we need 5x there. And then 8 divided by negative 4 is negative 2. And let's double check, make sure we did this right. Negative 4 times 5x is negative 20x. 3x times negative 2 is negative 6x. And so this whole thing, we should get 15x squared, negative 20x minus 6x minus, that's negative 26x. Wow, I can't write. Plus 8. Yep, that's exactly what we wanted. That was the area. Okay, now we're going to go on to some special products of binomials. Here's the really good news. All of this is just shortcuts. I'm going to make a note. This is just a shortcut. So it's helpful, but all of these things that we're going to do, you can do by just doing the box method. So here's what I mean. Oops, I made a typo. This should say x plus 3 squared. Please correct that for me. My bad. That should be x plus 3 squared. Square that sucker for me. Okay, that's better. So we have this formula. If you have the quantity a plus b squared, that's the same as a squared plus 2ab plus b squared. So it's a shortcut. Instead of having to do the box method, if you have this format, here's a formula. So here's what this means. X plus 3 whole quantity squared, that's the same as x plus 3 times x plus 3. So there are two ways to this. We could look at our formula. We say that in where a would be, we have x, so a is going to be the same as x. And where b would be, we have 3. So b is 3. So then we're just going to use this formula. Our formula says we have a squared, which is really x, so we have x squared, plus 2 times a times b. So plus 2 times a, which we said this instance is x, times b, we said b is 3, plus b squared. So plus 3 squared. Let's simplify this a bit. Ooh, I don't know why I put the squared on the inside there. So x squared, well that's just x squared. 2 times x times 3. 2 times 3 is 6. And then x. Plus 3 squared is 9. So there's our answer. Let's double check. Let's do the box method and see if we get the same thing. So here's another way to do the exact same problem. X plus 3 and x plus 3. X times x is x squared. 3 times x is 3x. 3 times x is 3x. And 3 times 3 is 9. So we get x squared. Then don't forget to add these. 3x plus 3x is 6x plus 9. So yeah, that formula works, but you don't have to memorize it. You don't have to ever use it because you can always use the box method. Try out this one, 2x plus 10 quantity squared. Okay, hopefully you realize that a equals 2x and b is going to be 10. Then just use your formula. Instead of a, we have 2x. Instead of b, we got 10. So I'm just filling in my formula. That's how I got all those numbers. Then watch out. Remember, our exponent rule says that when you have this going on, you have the parentheses and exponent on the outside. Everything on the inside needs to get that exponent. So we get 2 squared, x squared, plus, you know what, I'm going to put all my coefficients together. 2 times 10, and then put the x at the end, plus 10 squared. All right, well, 2 squared is 4. We got to keep x squared as x squared. 2 times 10 is 40. Don't forget your x. And 10 squared is 100. There's your answer. On to the next page. All right. The other shortcut is called difference of squares. So again, this is a shortcut. You never have to use it. You can always use the box method. But if you see something like this, a plus b times a minus b, that's the same as a squared minus b squared. So here's what we mean. We got x plus 4, x minus 4. So instead of a, we now have x. Instead of b, we now have 4. Well, this formula says that we can have a squared, so x squared, minus whatever b is, that's 4 squared. Well, that's x squared minus 16. And if you want, you can double check, use the box method. So you can also use the box method. And if you want to, do that. Check it out, see if it works. It should. Let's see if you can do this one. First, label what your a and what your b is. Should get a is 2x in this example. B is 5. All right, we'll use our formula. So we have a squared minus b squared. And again, exponent rule says that everything on the inside needs that exponent. So we get 2 squared x squared minus 5 squared. All right, 2 squared is 4. X squared is just x squared. And 5 squared is 25. And please notice that minus sign was not included when we squared it. So it stays that minus. So we just end up with 4x squared minus 25. One last example. You can always use the box method when multiplying polynomials. So for example, this is not a special case. This is not a special binomial. So we have to use box method on this one. But any of the examples we did, excluding the division ones, can use box method. So let's do box method for this one. Set up your box. Alright, so you should have a box like this. It might be hopefully a little neater than mine. And let's go for it. So top left box, 4x times 2x, that's 8x squared. Top right box, you get 4x times 3, which is 12x. Bottom left box, 2x times negative 1 is negative 2x. And bottom right box, negative 1 times 3 is negative 3. All right, let's write it out in standard form. Don't forget that we're going to need to combine these. We end up with 8x squared. Then 12x minus 2x is positive 10x. Then minus 3. That's it.